All right. Hello, guys. So today we are going to be taking notes on communication systems. If you have not already, make sure that you are logged on to your Google slide, which is on your Google Classroom. This is where you guys are going to be taking your notes and following along as you watch this video. So just to get started, when I am paused, you guys are going to be typing in what you see up on the projector. Okay, or on your screen if you're watching it on your screen. And so let's get started. So just like transportation systems, communication systems are made of different subsystems. So they're made of all different parts that help a system work. And we use communication systems all the time and every day. So we're going to learn about those different parts. The only thing that's different is that in communication systems, there is an order to how the subsystems work. Unlike transportation systems, where all the subsystems are just kind of there and they all work together at the same time, there is a process and a step-by-step sequence to how communication systems work. So first off, we need to figure out what communication systems are. So communication systems are any system that describes how a message, how messages are exchanged or sent from one location to a destination. So they're a system that describes how messages are exchanged or sent from one location to a destination. If you want to pause, you can type this in. Okay, and so like you can see in this picture here, we do have lots of different types of communication systems. We have a cell phone, we have letters, radio, news, TV, and satellite. And all of them have the same list of subsystems that they use in order to deliver a message from one place to another. And so there are 7 subsystems to a communication system. And like I said, these go in order. So the first subsystem is the source, then the encoder, the transmitter, receiver, the decoder, storage, and the destination. And so you can pause and you can type this in onto your slide. All right. And so we're going to go through each of these subsystems. We're going to type in the definition, and we're also going to look at 3 different examples of communication systems. We're going to look at a computer, we're going to look at a radio, and we're going to look at a cell phone call. And we're going to talk about at what point in that system do we find the source or the encoder or the transmitter or the receiver. And so we're going to start off with the source. Oh, actually, we're going to start off with watching this video, and I'm going to try to play it. If it doesn't play, you can skip through this part and then just play it on your own YouTube account. So let's open this up.
Do you remember when you first realized that your computer was more than just a monitor and keyboard? That between the mouse click and the video playing, there was something that captured your attention, understood it, and made it real? What is that something? Is it gremlins? Let's imagine that we can shrink down to the size of an electron and inject ourselves into a click of a mouse. If you took your mouse apart, you'd see that it's really a very simple machine. It has a couple buttons and a system for detecting motion and distance. You might have an optical mouse that makes these measurements with lights and sensors, but older ones did this with a hard rubber ball and some plastic wheels. Same concept. When you click the button on your mouse, it sends a message to the computer with information about its position. When your mouse click is received, it's handled by the basic input-output subsystem. This subsystem acts like the eyes and ears and mouth and hands of the computer. Basically, it provides a way for the computer to interact with its environment. But it also acts like a buffer to keep the CPU from being overwhelmed by distractions. In this case, the I/O subsystem decides that your mouse click is pretty important, so it generates an interrupt to the CPU. Hey CPU, got a click here. The CPU, or central processing unit, is the brains of the whole computer. Just like your brain doesn't take up your whole body, the CPU doesn't take up the whole computer, but it runs the show all the same. And the CPU's job, its whole job, is fetching instructions from memory and executing them. So while you're typing, maybe really fast, like 60 words a minute, the CPU is fetching and executing billions of instructions a second. Yes, billions, every second. Instructions to move your mouse around on the screen, to run that clock widget on your desktop, play your internet radio, manage the files you're editing on the hard drive, and much, much more. Your computer's CPU is one heck of a multitasker. But oh my gosh, there's a very important mouse click coming through now. Let's drop everything now and deal with that. There are programs for everything that the CPU does. A special program for the mouse, for the clock widget, for the internet radio, and for dealing with letters sent by the keyboard. Each program was initially written by a human in a human-readable programming language like Java, C++, or Python. But human programs take up a lot of space and contain a lot of unnecessary information to a computer, so they're compiled and made smaller and stored in bits of ones and zeros in memory. The CPU realizes that it needs instructions for how to deal with this mouse click, so it looks up the address for the mouse program and sends a request to the memory subsystem for instructions stored there. Each instruction in the mouse device driver is duly fetched and executed. And that's not nearly the end of the story. Because the CPU learns that the mouse was clicked when the cursor was over a picture of a button on the monitor screen, and so the CPU asks memory for the monitor program to find out what that button is. And then the CPU has to ask memory for the program for the button, which means that the CPU needs the monitor program again to show the video associated with the button, and so it goes. And let's just say that there are a lot of programs involved before you even see the button on the screen light up when you clicked it. So just the simple task of clicking your mouse means visiting all of the critical components of your computer's architecture. Peripherals, the basic input-output system, the CPU, programs, and memory, and not one gremlin.
All right. So let's go back to our notes here. Okay, so now we're going to start off with the 7 subsystems. So that video is a much more in-depth type of video and explanation of a communication system than we're going to really go into. But it gives you guys a basic idea that there are a lot of different steps to just using a computer, to just clicking your mouse or typing in the keyboard or looking something up on the internet. So the first subsystem is the source. And so the first thing you guys want to do is type in this definition right here. So where the information is coming from, that is the source. The source is the start of the communication system. So it's whatever has the message and is trying to get it to go somewhere. For example, we have our 3 systems. So in a computer, it's the person using the computer. On a radio, it's the radio host that's actually speaking into the microphone or playing music. And in a phone call, it's the person that's talking. So the source is usually the person that is trying to send the message, because they have the information or the idea or whatever they want to do, and they have to get that message across whatever communication system they are using. So you can pause, type this in, and then drag and drop all your GIFs and pictures into the boxes below. All right. After the information is known, or whatever you are trying to send, after the source, we have the encoder. So the encoder, here's your definition right here. The encoder is the device that changes the message into another form before transmission. So it's the device that's going to take that message from the source and change it into another form before it transmits somewhere, okay, or moves somewhere. The way I like to think about this is that when you are trying to communicate through different devices, like a cell phone or a computer or radio, you don't speak computer language, okay? You don't speak radio language. You don't speak phone call language. You have to somehow encode or change your message into electrical signals that the computer can understand, that the microphone can understand, that the cell phone can understand. And we do that with the encoders. And so in a computer, the encoder is the mouse or the keyboard. So again, I know that I am the source and I want to look up a funny dog video on YouTube. So I'm going to take that information and I'm going to encode it by using my keyboard. I'm going to say funny dog video and I'm going to type in the letters and then I'm going to press enter. Typing in those letters is changing my information, my source, into computer code. Okay, it's telling the computer that's what the source wants to do. If it weren't in code, nothing would ever happen. Okay, unless you're using like voice to talk or whatever. In a radio, it's actually the microphone. So we learned in energy, in different types of energy forms, that our voice has sound energy. And when we speak, our voice travels in different series of waves and frequencies. And those waves and frequencies will go into the microphone. And when they are kind of bouncing against the pieces of the microphone is picking up all of those vibrations and changing them into electrical signals. That's called encoding. It's taking your human language and it's making it into electrical signals. It's encoding it into the form that it needs to be in before it can move. Same thing with a cell phone, kind of like the radio. Your phones have a microphone on them. So when you're speaking, they can pick up on your voice and the waves of your voice and then transform or change them into electrical signals. So again, I'll pause if you need to, and you can kind of type and drag and drop your pictures. Be sure that you guys get the definition down as well. All right, so after we have our message encoded, so I'm the source, I gave the message, I encoded it into whatever device I'm trying to use by either using the keyboard or speaking into a microphone, and now that message is in the right form. So now it's ready to move. That message is going to move through a transmitter. And so the transmitter is the device that takes the code from an encoder and it's going to send it out. Right? So it's the device that's going to take that code that's already ready to go. It's changed into whatever language it needs to be in, and it's going to send it out. It's kind of like the mail carrier. It's the person that's actually, or the thing that's actually moving something. Transmitting means to move something. So it's sending the message out. So in a computer, this would be the internet. If I typed in funny dog video and I press enter, now the transmitter needs to be the internet that's going to carry that message to go find what I'm looking for. In a radio, it would be the radio transmitter. So those electrical signals are going to get sent out by a radio transmitter. In a phone call, in a phone call, it would be the cell tower. So this is a little bit interesting because people often don't exactly know how cell phones work. We know that there's cell towers. We know that if there's more cell towers, we typically have better service. But what does that mean? So if you are trying to have a phone call with somebody and I'm in Bridgewater, and let's say the person I'm trying to call is in Rainham. So when I make that phone call, I'm going to encode my voice. I'm the source. My voice gets encoded into my phone. It's going to get transmitted through cell towers from cell tower to cell tower, depending on where they are. So for example, I'm calling that person in Rainham. My cell tower is going to transmit my voice or my signal to the cell tower in Rainham that's closest to my friend's phone. Okay. And this can jump from cell tower to cell tower to cell tower. And that's why we're able to have these conversations across the world. And that's why we're able to communicate with people that are very far away from us, is because it will keep going and jumping and transmitting from cell tower to cell tower. You guys can pause and type those in. So after the message has been sent out, there has to be something on the other end that's going to pick that message up. And I like to think of this as like if we were playing football. If I'm playing football and I am the source, I know the play that I'm going to do. I know how I'm going to throw the football. I have the football in my hand. The football is encoded because it's a football. It's ready to be thrown. And I go to transmit that football. I go to throw it. There has to be a receiver on the other end. Otherwise, that message is dropped. Okay. And so the next part is the receiver. And the receiver is the device that's going to take in that signal transmitted by the transmitter. So it's taking in that signal that's transmitted by the transmitter, and it's whatever's picking up that signal. If there's nothing on the other end, if the receiver is broken or it's not there, the message may not be sent. So for example, we have a computer. It would be the computer tower and processor. So when you send it off to the internet, your computer tower and processor has to kind of pick that signal up, whatever the internet is sending to it, saying this is what that person is trying to look up, and that it's going to process what your initial message was. So if you're looking up funny dog video, it's going to process, okay, where am I actually supposed to display or show this message that she's trying to achieve? In a radio, it's the radio antenna. So like the antennas that you guys see on your cars, or like a walkie-talkie has an antenna on it, or if you're just listening to a classic radio, sometimes they have antennas on them. Not so much anymore, but they used to. And so those antennas will pick up that message by the transmitter. So they are the receiver. In a phone call, it can be the cell tower or the person's phone. So it depends. Like I said, if I'm trying to call across several towns, it's going to go through this process of being transmitted and received and transmitted and received and transmitted and received through each cell tower until it gets to the cell tower that's closest to the phone. Once that cell tower that's closest to the phone receives that message, then it's able to transmit it to the phone. Now the phone becomes the receiver. So this process can kind of keep going until that message gets to where it needs to be. That's kind of why if you are kind of traveling through states and you're listening to the radio, sometimes your radio goes out. You have to change the station. It's because the transmitters that are sending out radio signals do not go as far as like cell towers go. Okay. So you can pause, type that in. Okay. So that is our receiver. After the message has been received, the issue that we have is that that signal or that message is still in the computer language or the radio language or the phone language. It's in those electrical signals. We don't speak electrical signals. We speak human language. And so now we have to go through what's called a decoder. So something is in code. It's been put into that electrical signal language. Now we have to have the device that's going to take that code. It's going to translate the encoded message into an understandable form. Okay, so it's the one that's going to undo the encoded message. Encode, the prefix en kind of means go into, so it's going into code. Decode means to take it out of code, okay, or uncode it. And so this is the device that's going to then translate that electrical signal back into what we're actually looking for. In a computer, it's the input-output system in the tower. So again, this is what's deciding, okay, we're trying to display on the screen a funny dog video. So the input-output processor is going to say this electrical signal needs to be undone and displayed on the screen so that the human who is watching it can actually understand it, right? I don't speak binary code. I don't speak electrical signals. So I need to actually see the display pop up of my video. In a radio, this is the radio itself. The radio is going to decode those electrical signals given off by the radio transmitter, and it's going to decode it and play the actual music or the person's voice that's hosting the radio show. In a phone call, it's the second cell phone. So our cell phones are the encoders and then also the decoders. So when that phone call is received by the cell tower, it's still in the electrical signals. Your cell phone will decode that message and play through the speaker so that you can hear the person's voice that's talking to you. So you can pause, type that in. All right. Now that message is decoded, one of two things can happen. So if that message is sent, and it's not ready to be viewed just yet, it's going to go into what's called storage. Storage is the place to hold information to access later. It can either be internal or external. Internal meaning that it's actually physically in the system. External meaning that it's somewhere else, okay? It's not actually a part of the system. And so we understand that when we are looking things up on the internet, our web pages and our computers have storage that is going to keep a history or a log of what we're typing, what we're looking up, so that if we want to access this information later, it's already right there. For example, when you go to Google anything, and let's say I want to type in the best chocolate chip cookie recipe. Well, after I look that up, the next time, even if I'm on a different device, I go to look up the best chocolate chip cookie recipe. If I'm logged in under my Google account, as soon as I type in the best, chocolate chip cookie recipe is going to pop up as an option. That's because there's external storage somewhere else, the cloud, that is keeping that information until I want to access it later. In a radio, there is no storage unless you are recording it, right? So we know that radio is live. Once it happens, you cannot replay that message. Phone call, we have memory cards. Phones also have internal storage and external storage. So again, we can save things on our phone. Like we can back up our pictures to the cloud, and we can back up our files or our contacts to the cloud. And so when we get a new phone, we don't actually have to physically move all of our pictures from phone A to phone B. We can just pull them from that server, wherever that external storage was, and download it onto our phone. We also have memory cards, like we know that we can save things on and then access later. So that is storage. If the message is ready to be accepted or viewed or accessed, we have reached the end point of communication, which is the destination. Okay. Your communication systems will always go from source to destination. The destination is the end point of communication. That's where we're trying to get the message. In a computer, it's the person that's watching the screen. It's the person that's typing in that video and trying to watch the screen. It's the person that is listening to the music on the radio. It's the person that's actually receiving the phone call. And so when that message goes from the source all the way through those steps and reaches the destination, we know that the communication system has worked. It was successful. All right. So let's practice together. We are going to look at a basic communication system. So this is a picture or a depiction of how GPS works. Okay. And so GPS is where we are in the world, uses satellites to tell people where they are. So that's a communication system, right? They're trying to communicate your position, right, in this world. So it's going to go through these 6 steps. So I'm going to give you a second. You guys are going to actually click onto your next slide. On your next slide, you'll see that you have drag and drops of where these different subsystems belong. Okay, and I wanted you to take a minute, try to do your best, and when you're done, we'll click on to the next slide. All right, so if you have finished, we are going to look on to the next slide. And so we see that this is our answer. The base station is the source. The base station is where the information is coming from. That base station is going to then encode the message through a dish because the base station doesn't speak satellite signal. So the dish does. It has to encode into a satellite signal. That satellite signal is then transmitted by the satellite and then received by the boat. The boat is also going to decode the message back into whatever display is showing the GPS, right? So that the humans that are on that boat can read that message, because ultimately the humans are the destination. They need to know their position in the water. Okay. If we look at a couple other examples, we can talk about a cell phone. Okay. In a cell phone conversation, we have the source. Cell phone number 1 is going to encode the person's voice. Then we go through this series, like we said, of transmitting and receiving and transmitting and receiving between cell tower and the MTSO, which is the place that kind of decides which cell tower it needs to go to. Cell tower number 2, transmitted and received. And then it goes to cell phone number 2, transmitted and received by cell phone number 2. Cell phone number 2 decodes the message, turns it back into an understandable language that we can hear, and it reaches the destination, the person who is calling. And if you think about it, when I have, if you have a phone call, and let's say you're even in the room and I'm calling you in the room, and you put me on speakerphone, my voice that I am speaking into my phone is just slightly delayed on your phone. That's because it has to go through this process. It's going to take a little bit of time, even if it's a slight delay. Our next example that we have is a radio again. So our voice gets encoded into electrical signals by the microphone. The microphone is then going to transmit those signals through a radio tower. The radio tower transmits those signals to the antenna of the radio. The radio is going to decode that message and then play the music or the show or whatever message is trying to be put across to the destination, which are the people listening to the radio. And in internet, this is an example of kind of like if you're uploading something to Google Docs, something that's going to be saved online. So the person that is actually typing on the Google Doc is the source. The web page is what's going to encode what that person is typing in onto the web page. Then it's going to transmit through a server to be received by the internet connection. The internet connection is what's going to then either hold it in storage if it's not ready to be viewed yet, okay? Then it would get decoded and it can be viewed by the destination. Or it's going to be sent right to the destination and decoded by that destination's computer. Okay? So if you guys need to go back and rewatch any of these slides to type things in, you may. And I will see you guys tomorrow. Have a great day.